Hello everyone, welcome to my channel. In the previous lectures, we have seen the concept of mesh analysis and few solved problems on mesh analysis. In this video, we discuss super mesh analysis. Super mesh. When a current source is present between two meshes, we remove the branch having the current source and then the remaining loop is known as a super mesh. Procedure to be followed here are step 1 is to identify the number of meshes. Step 2, assign the mesh currents. Step 3, look for the meshes which does not contain any current sources. Apply KVL to that mesh. Step 4, remove the branch having common current source between the meshes and apply KVL to that super mesh. Write the net currents in current sources. Sixth step, solve the KVL equation to find the mesh currents. Let's discuss problems. Determine the current in the 5 ohm resistor in the network given below. We are supposed to determine the current in this 5 ohm resistor in the network given below. You can see here we can solve this problem using super mesh analysis because you have here current source between two meshes. Step 1. Number of meshes. Identify the number of meshes. This is mesh 1, this is mesh 2 and this is mesh 3. Number of meshes equal to 3. Step 2, assign mesh currents. I would like to assign here I1, here I2, this is I3. You can take even in anti-clockwise direction. Assign mesh currents in 3 meshes. Let it be I1, I2 and I3. Step 3. Step 3 is to identify the mesh which does not contain any current source and apply KVL to that mesh. If you observe here, we have 3 meshes, mesh 1, mesh 2, mesh 3. Mesh 2 contains a current source 2 amps. Mesh 3 contains a current source 2 amps. Whereas mesh 1 does not contain any current source. So we can apply KVL to loop 1. Applying KVL to mesh 1, we can write minus 50 plus 10 into I1 minus I2, because here in 10 ohm I1 is flowing in this direction, I2 is flowing in reverse direction, plus 5 into I1 minus I3 equal to 0. In 5 ohm resistor, I1 is flowing in this direction, I3 is flowing in reverse direction. I can rewrite this as 15 I1 minus 10 I2 minus 5 I3 equal to 50. Let this be equation number 1. Step 4. Current source is present between meshes 2 and 3. Therefore, meshes 2 and 3 forms a super mesh. Meshes 2 and 3 forms super mesh. I can redraw the figure like we need to remove the branch which is having current source. This is 1 ohm, 2 ohm, 10 ohm, 5 ohm and 50 volts. Just indicate the currents. This is I1, I2, I3. Apply KVL to the super mesh now. Applying KVL to super mesh. Super mesh is meshes 2 and 3 forms a super mesh. Let us start with writing voltage drop across 10 ohm. 10 into I2 minus I1 plus 2 into I2. Next 1 ohm plus 1 into I3. Next 5 ohm plus 5 into I3 minus I1 equal to 0. Equal to 0. This equation can be rewritten as minus 15I1 plus 12I2 plus 6I3 equal to 0. Let this be equation number 2. Next, step 5. Step 5 is to write the net currents among all current sources. We have a current source 2 amp. If you observe the circuit, I2 is flowing in this direction and I3 is flowing in the same direction as 2 amps. Therefore, you can write the net current as I3 minus I2 equal to 2. Let it be equation number 3. The current which is flowing in the same direction as current source should be taken as greater current than the other current. So here I3 is flowing in the same direction as 2 amperes. So I3 is taken as a greater current. We can write net current as I3 minus I2 equal to 2. This is equation 3. Last step, solving equations. Solving equations 1, 2 and 3. We obtain mesh currents as I1 equal to 19.99 amps, I2 equal to 17.33 amps, I3 as 15.33 amps. These are the mesh currents obtained. What is the question? We are supposed to find the current in 5 ohm resistor in the given network, right? Current in the 5 ohm resistor is given by I1 minus I3, that equal to 19.99 minus 15.33, which is equal to 4.66 amperes. This is the answer. Because in 5 ohm resistor two currents are flowing, I1 and I3, which are flowing in reverse direction. You should take the difference, I1 minus I3, that equal to 4.66 amperes. Let's discuss second problem. Determine the power delivered by the voltage source and the current in 10 ohm resistor for the circuit shown. Here you can see there is a current source here 3 amp and another current source 10 amperes. Let us identify meshes first. Step 1. Number of meshes equal to, let this be I1, let this be I2, let this be I3. Mesh 1, mesh 2, mesh 3. Number of meshes equal to 3. Step 2. Assign mesh currents I1, I2, I3. Step 3. Identify the mesh which does not contain any current source. Let us see here. This is mesh 1. It is containing a current source. Mesh 2. It is containing a current source. Mesh 3. It is containing a current source. So we could not identify any mesh which does not contain any source. So we can skip step 3. Next, step 4. Remove the branch having current source. Corresponding meshes will form a super mesh. Apply KVL to it. Let us redraw the figure. So current source which is common to two branches is removed and indicate current flow as it is I2, this is I3. And step 4, meshes 1, 2 forms a super mesh. Applying KVL to super mesh. I'll start from 50 volts, writing voltage drop minus 50 plus next 5 ohms, only I1 current is flowing, 5 into I1 plus next 3 ohm plus 3 into I2 plus 2 into I2 plus 10 into I2 minus I3 plus 1 into I1 minus I3 equal to 0. By rewriting this equation as 6I1 plus 15I2 minus 11I3 equal to 50. Let this be equation number 1. We have applied KVL to the super mesh. The equation obtained here is this one, equation number 1. Next step is to write the net currents for current sources. Step 5, we have a current source 3 amp. Let us see the directions of I1 and I2 flowing in the 3 amp. Here you can see I1 is flowing in this direction, I2 is flowing in the same direction as 3 amp from the figure. From the figure you can see I1 is flowing in the reverse direction of 3 amperes and I2 is flowing in the same direction of 3 amperes. Let us indicate the same here. I2 flowing in same direction, I1 flowing in current direction. The current which is flowing in the same direction is greater than the other current. We can write net current as I2 minus I1 equal to 3. Let it be equation number 2. And from the loop 3 or from the mesh 3, we can write here directly I3 equal to 10 amp. Because there is no other source here, we can write I3 equal to 10 amp. Let this be equation number 3. Now using equations 1, 2 and 3, we can solve for mesh currents. Step 6, solving equations 1, 2 and 3. We get I1 equal to 5.47 amp, I2 equal to 8.47 amp, I3 equal to 10 amperes. Next, what we are asked to find? We are asked to find the power delivered by the voltage source and current in 10 ohm resistor. Current in 10 ohm resistor is given by I3 minus I2. You can see in the figure this is 10 ohm resistor. Okay, two currents are flowing in this resistor. One is I3 and another one is I2. I2 is flowing in this direction, I3 is flowing in this direction. So you can write current flowing in 10 ohm resistor as I3 minus I2. 10 minus 8.47, which is equal to 1.53 amperes. Power delivered by voltage source. Power delivered by voltage source equal to V into I1. Voltage source, we are taking it as 50 voltage source into I1 is given by 5.47. In the question we are asked to find the power delivered by 50 volts voltage source, which is equal to 273.5 watts. These are the final answers. That's all for this video. Thank you.